Our work focuses on the challenging task of referring expression segmentation, which aims to predict the per-pixel segmentation of a region referred to by the language expression in an image. Most of the existing RES approaches require massive pixel-level annotations, which are expensive and exhaustive. In this paper, we propose a new partially supervised training paradigm for RES, which means training using abundant referring bounding boxes and only a few pixel-level referring masks. To maximize the transferability from the REC model, we construct our model based on the point-based sequence prediction model. Because it is very easy to transfer from box to mask in the sequence prediction model. Box is predicting 2 points and mask contour is predicting multiple points. Only the number of predicted points increases without changing the model structure. Next, we will describe our motivation in detail. Existing REC and residential models are usually of these two paradigms. One is to train REC and residential independently by connecting different heads, box head and mask head after the shared model, and different loss functions are used for both REC and RES. The other is to sequentialize both box annotation and mask annotation, and train REC and residential using the same sequence prediction model, making the representations of the two tasks consistent and possibly with better transferability. We trained the REC model on both models with 1% mask labeled data to complete the residential task, and the results show that the sequence prediction model seq-TR has significantly better transferability than the traditional multi-headed model. Therefore, we propose a partially supervised training paradigm. The partially supervised paradigm is a training approach between fully supervised and weakly supervised. Specifically, it trains the model with a full box label and a small number of mask labels to complete the segmentation task. Figure 1 shows the overall architecture of our method, and Figure B is the suggested training steps of our method in the partially supervised residential task. We propose the co-content teacher forcing to make the model explicitly associate the point coordinates, scale values, with the referred spatial features, which alleviates the exposure bias caused by the limited segmentation masks. Our training steps are divided into 3 steps. Step 1. REC training. Since in the partial RES task, all the bounding box labels are seen in the model training, we first train the model on fully supervised REC to get a better representation relatively of multi-model features from the encoder output. The feature will be used to enhance TF learning in the next step of residential training. In practice, we load the REC model trained in seq-TR as a pre-trained one. Step 2. Initial residential training. In this step, we train the model with only 1%, 5%, and 10% labeled mask data on the residential task. The model is equipped with the new method proposed in this paper, including CCTF and PMCA. Step 3. Retraining with pseudo-points. After obtaining the residential model from Step 2, we can utilize it to generate more pseudo-contour points. While these points may contain a lot of noise or may not match the way labeled data is sampled, so we reselected and sampled out the appropriate pseudo-points with the proposed RPP strategy. To fully utilize the data without mask annotation in partial RES, we retrain the model with the generated pseudo-labels, and we present a resampling pseudo-points RPP strategy. Unlike most pseudo-label works that directly use the network's predictions as labels, we select the appropriate pseudo-masks with dice coefficient and then resample the predicted points in a uniform way to regularize the contour sequence labels. With extensive experiments, our method displays significant improvement compared to seq-TR baselines on all 3 benchmarks, i.e., at an average of 3.5%, 2.4%, and 3% on 1%, 5% and 10% mask labeled data. With 10% mask annotated data, our method achieves 97% of the fully supervised performance on RefCoco Plus at Val. We are also able to achieve 88% of the fully supervised performance only with 1% mask label data on RefCoco Plus at Testa. We have done detailed ablation experiments, which can be found in the paper. We evaluated the segmentation performance of our method at various ratios, i.e., 1%, 5%, and 10% of partial RES data in Figure 5. As the mask label data increases, the contours fit more accurately. By comparing these results, we observe that with a low percentage of mask label data, our segmentation results are already similar to those of the GT points. For more details and experimental setup, please read our paper. Our code will be available. Welcome more references and stars. That's all, thank you.